All right. I'm going to load this in a new tab. I fixed it. I fixed our issue. Okay. Now, warning, this connection is structured for. You just continue because I've set them up all that way. So now we can actually see what the heck we're working on, right? All right. This is the wrong assignment. So of course, let me log out again. Oh boy, this has been something. All right, let's go to the assignments because that's not the assignments I wanted. I want to correct this one. Oh, right here. Yeah, you can see what all I have to go through. So if I want to edit this assignment so that I can see the sucker, all right. So I load it, load it, load it, load it, load it. And then I got to come down here. I keep forgetting to hit this button right here. Load this tool. Yeah, I can say a lot of things about load this tool. All right, anyway, so there we go. Now, boom, hit that sucker, bang, and saying, hey, we can't resolve this because you're an idiot. No, you're an idiot. All right, so let's take a look at problem 5, and then you guys can do problem 6 on your own. All right, so I've got a block, 42 kilograms. I've already tried this problem once, all right, and it's 12:12. I am going to be done with this thing by 12:25, all right, and we'll be on our way. So 40. Let me write down the information we need. M equals 42 kilograms. If this is a block of ice this big, all right, this looks like it's about at least a half a cubic meter of ice. That would be almost 500 kilograms. And they're saying it's 42 kilograms. Shoot, I bet, what's 42? Well, yeah, 42 kilograms is ballpark, what, 8,500 pounds? So that's a big chunk of ice, but not this big a chunk. All right, anyway, 0.1, mu of k is 0.1, or mu of s is 0.1. That's our static friction, and mu of k is equal to 0.03. All right, notice they're just numbers, and we got to find, and the angle is 25. All right, to do any of these problems, step 1, 3 points on the exam. If you're given a problem that's kind of like this or something familiar, draw the freaking forces. All right, that's physics 101. You draw the forces. All right, so let's get to my ladybug here, and we can figure this out now. All right, we've got everything we need. She's an artist. She don't look back. All right, so here's my block of ice. It's got an mg going like this. It's got a normal force going like this. Okay. Now that notice I drew the normal force bigger than mg. Why? Because it also has, I'm going to draw this force over here of 25, that's going 25 degrees this way. There's my 3 forces. One's cattywampus, one's at an angle. Let's put it in its, now normally, and it's got a kinetic frictional force going this way, or static frictional force going that way. Let's write down the formulas that we know. We know that the normal force, we know that the static frictional force is equal to mu of s times the normal force. Well, I don't know the normal force just yet. All right? I know I'm moving it at a constant speed, so my acceleration is equal to 0. So I'll take the sum of the forces in the x direction is equal to 0. The sum of the forces in the y direction is equal to 0. All right? Now, I'm going to draw my diagram again. Normal force, big normal force, not quite as big as mg, F1 of x, F1y, which is probably less than that, static frictional force. There are my 4 forces. I didn't draw those very straight, but they're supposed to be all in the x and y direction now. So the sum of forces in the x direction are equal to F1x, which is F cosine of 25, minus F of s, But wait, F of S is equal to the normal force. Well, I got to figure out what the normal force is. Here's my normal force. I know this is equal to the positive one. Let's just go around the horn. Positive force, normal, that's an N, minus mg, minus F sine of 25, because that's my x component of F1. Okay? This is where I messed up on the last one. All right, so now, so what's the normal force equal? Because I need to find out what this normal force equals up here. And I find that in my y-axis, because it's the perpendicular force. All right, so F of n is equal to mg plus F sine of 25. All right, so now I take the magnitude of the normal force is equal to mu of s times mg plus F sine of 25. So therefore, I'm just going to say it's mu of s of mg plus mu of s, and there's where I got in trouble last time, F sine of 25. Now the rest is just dibbling and scribbling with algebra. All right? So go back to some of the forces in the x direction, which are equal to 0. And I wind up with, because the acceleration was equal to 0, because it said, so I wind up with F cosine 25 minus, here's what F of s is equal to, minus mu of s times mg plus mu of s times F sine of 25. Hey, look at this. The only unknown that I have are these two guys. That's the only unknown. Gotta get that out of my way. That's driving me bat crazy. All right, now, so let's take this big block of stuff here. Now let's not take the big block. Let's just get rid of the parentheses. So we got F cosine of 25 minus mu of s mg plus mu of s F sine of 25. So that's all equal to 0. So get this on the other side. So I've got mu of s of mg, where m is equal to 42 kilograms, is equal to F cosine of 25. See, because I added this guy to both sides. Minus mu of s, this is where I messed up last time, F sine of 25. So mu of s times 42 times 9.8 is equal to F, factoring that out, cosine of 25 minus mu of s sine of 25. Lots of algebra, I get it, but you can't do physics without algebra. All right, so let's figure out what all that is. So I'm just going to do the cosine of 25 stuff. I'm just going to do the stuff in the parentheses here. Cosine 25 minus 0.1 times the sine 25. Ooh, I just need one parentheses there. 0.864. So this is F times 0.864. And this is equal to, on this side I've got 0.1 times 42 times 9.8. Oh, I didn't mean to hit the negative. 41.1. I did not mean to hit the negative sign there, if you saw that. Now, what do? Divide both sides by 0.864. And I get 47, after I did some algebraic shenanigans because of my mistake earlier, 47.6. So F is equal to 47.6 newtons. All right, tough guy. Let's see if you're correct. 47.6. Hoorah! Now, part B. Part B, real quick. Oh, I've got 3 minutes to do part B. We can do now. What is the acceleration? If that force is maintained. Okay, so I'm going to push. So now remember, F is the force that's coming down on it. All right, it's coming down at that angle of, but the acceleration is only in the x direction. All right, so I have to be careful with this. God dang it! Probably some siding asshole. No, sorry. Sorry. Anyway, so here's what we're going to do. To get the acceleration, now, once again, we got to look at all the, so there's going to be, right when it starts to move, there's going to be an acceleration. We've got the same diagram, but at least now we know what F is. So we've got, let's go back to my thing here. So we've got 47.6 times the cosine of 25 here. We've got 47.6 times the sine of 25 here. And we've got f of k now. To just get it to move, and in other words, we're going to do that little jerk thing. It's going to get it to finally break free of f of s. It's within an instantaneous amount of time, it's going to start sliding, and we're going to push it with an acceleration. And I've got mg here, which is 10 times bigger than that force. Mg is huge. And I got the normal force going up here. So remember, we got to get f of k is equal to mu of k times the normal force. Well, some of the forces in the y direction tell us where because it is that. Now, we've got an acceleration going this way and this one. So we've got 0. For y, we've got 0 is equal to Fn. We're getting the same thing. Minus mg minus 47.6 sine of 25. Okay? Starting to run out of page there. Minus the sine of 25. All right? So we've got mu of k, which is 0.03, times the normal force, which is going to be these guys added up, right? Because Fn is equal to mg plus 47.6 sine 25. mg plus 47.6 sine of 25. Sorry, I made that sloppy. That's what you get when I get in a hurry. So let's just plug in those numbers. So I got 0.03 times 47.6, 0.03, parentheses, times 40, m is 42. 42 times 9.8 plus 47.6 sine 25, close that parentheses, close the whole thing, boom, 12.9, okay. What? Oh, that's the kinetic frictional force. Yeah. So F of K, sorry, is equal to 12.9 newtons. Forgot what I was solving for there. All right? Because we got the normal force, was right here, and then we plugged it in there. Okay? By the way, the normal force turned out to be 432 newtons. All right, there we go. Now, sum of the forces in the x direction is equal to MAX. We're trying to solve for MAX. All right, we're almost there. We're almost there. All right, which is equal to minus 12.9 F of K right here, plus 47.6 times the cosine of 25. Let's just go ahead and get that number. Negative 12.9 plus, I'm doing this in such a hurry. If this comes out right, it'll be a miracle. Cosine 25 is equal to 30.2. Yep, 30.2 newtons. So acceleration divided by 42 is equal to, oh, so I multiplied. 0.72 meters per second squared. Where did I get that AX? AX is equal to sum of the forces in the x direction divided by m. And let's see, 0.72. Let's see if that is correct. It'll be a miracle if it is, but you see how to do it. Oh, it was. All right, I rule.